So what we're going to do now, it's a bit of time, it's 11 o'clock. We are going to continue talking about the jumping lab. So most people did the initial analysis of the data that I presented and had some initial conclusions on whether the data supported their hypothesis or not. Does anybody want to share what they found?
I found out that the weight does not have anything to do with the height of the jump.
All right, so she did a scatter plot looking at people's weight versus how high they jumped and didn't see a correlation. So, that's evidence that weight really doesn't seem to be a good predictor of how high someone could jump. What we're going to be doing today is we're going to use a much larger data set, right? I talked about at the first week, there's a couple of errors you can make when you're kind of doing the statistics. There are these type 1 and type 2 errors. One of the errors you can get is there really is an effect, but it's lost in the noise. So you don't really see the effect just with the data that you've gathered. And sometimes a way to see an effect that actually is there is just to get more and more data. Kind of the more subjects you get, the more like the noise tends to kind of cancel it out. Like the people that are higher than normal versus lower than normal all kind of cancel each other out, and the true trends show up. Same thing the other way. Sometimes you think you see a trend, but when you get a larger data set, it kind of disappears because you just kind of got kind of an atypical group that you looked at. But it really isn't a common trend when you look at a larger population. So in general, the more subjects you have, the more likely you're going to see something that's real or not accidentally see something that's not real. So what we did with this initial analysis was, look at just a classroom's worth of data. And I wanted you to do that just to see if it supports your hypothesis. Also, just to kind of start thinking about how to analyze the data. Also getting some trust in yourself to make a graph without a computer, because I do find sometimes people like get nervous about making a graph, and most people did pretty good on that. But we are going to be looking at a much larger data set today, looking at data collected over a bunch of different class sections. And so we'll be doing the same kind of analysis that you did for this initial analysis, except we'll use a larger N and see if your initial conclusions are still supported. And in addition, we'll be able to look at lots more than just what you looked at, because we're going to be using these computer tools that make it much easier to kind of look at the data. All right, so weight. Did anybody look at something other than weight?
I used a calf size and there was no correlation.
Okay, so that's another one. Calf versus jump, and nothing really interesting there.
I looked at height and there was maybe some correlation, but some more data points would be great.
Right. So that's a pretty nice initial take on things. People looked at calf and didn't seem to do much. Weight didn't seem much. Height looked suggestive. We often use the word suggestive, like, oh, maybe there's something going on here. What else did people look at?
I looked at BMI, and it did not support my hypothesis that those in a healthy BMI would jump higher, but there was also almost twice as many healthy jumpers than non-healthy jumpers. So it's one of those things that I'd like to see with more data as well.
Right. And one thing while we're talking about BMI, I should mention, if you were going to look at like calf versus jump, jump height, centimeters versus calf circumference. Then it makes sense to do some kind of scatter plot for each subject what was their calf, what was their jump, and try to see if there's any kind of trend. And you draw the best fit line. If that line is horizontal, that means there doesn't seem to be much of a trend. For BMI though, some of the people who are looking at BMI drew a scatter plot, which isn't really that useful. Doesn't tell us that much. If we're using just healthy versus unhealthy BMI, that's going to make more sense to do some kind of a bar graph. Average jump in centimeters, healthy BMI, unhealthy BMI. If you're just comparing two categories, it would make sense to use a bar graph. So it's important to think about what's the most appropriate way to display your data. Other thing, a few people kind of reversed. Typically, you want to have your independent variable on the x-axis and the dependent variable on the y-axis. So it would be calf here, your jump height here. That's just kind of the convention, kind of the intuitive way to think about it. A number of people flip that, put like the jump height on the x-axis. So that would not be a typical way to display your independent and dependent variables. Units, always make sure you have units. Some people didn't have the units, right? If my calf is 36, what does that mean? It's 36 millimeters, I am a Barbie doll. Or it's 36 centimeters, maybe I'm a person. Or if it's 36 meters, maybe I'm an elephant. Or probably bigger than an elephant, like a giant elephant, right? So you always got to have the units there. Also, the best fit line, a number of people put best fit lines that I'm not quite sure where they were coming from. If your data is really clustered really strongly like that, then it's really easy to say, oh, my best fit line's like that. If your data is kind of more messy, but still kind of has some basic trends like that, you can still kind of get a best fit line. Kind of a rule of thumb is like half the dots should be above, half the dots should be below. When it gets more and more messy, it gets harder and harder to try to figure out what is the best fit line. With Excel, we just are going to do a mouse click and it's going to find it. Basically, it's a least squares fit. It's basically going to figure out, find the distance from every data point to the line and solve this equation so you get the line that minimizes the distance. It's the closest as possible to every single dot. So it's the line that best fits, approximates what the dots are doing. In Excel, it's going to be like, say, add a trend line. And it's just going to, do the math to calculate what is the line that is the best fit closest to every dot on your graph. So that's going to be a really useful tool as we go on later today, using Excel as a tool to analyze the data. So what I'm going to do now, what's the time? All right, so first I'm going to kind of set the stage for what your assignment is to finish up this jumping lab. And then I'm going to just show you these tools that you can use and just model some of the cool ways to analyze the data to help you see what's possible. This is not a lab where we're going to be doing everything all together for the whole thing. I'm going to basically spend some time showing you different tools, different techniques, and then you've got like the next couple of weeks to really just sort through the data to come up with your final story. But so jumping lab, kind of complete. Or maybe I should say extended analysis or something. So again, up to at this point, everybody's come up with a nice objective, hypothesis, done some initial conclusions from our first set of data. What we're going to do now is we're going to use an extended data set. Which I'll show you. It's accessible in the module right now. I'll show you where it is in just a second. And we're going to do a few things. One is, first thing is you're going to do just what you did. You're going to check to see if the data supports your hypotheses. Kind of what we just did, except now we're going to use a larger data set, and you'll get to use Excel, a computer program, to help you do the graphing and the curve fitting and things like that. You know, and you know, compare. So one, the first thing you're going to do, check if the data, this extended data, supports your hypothesis, and compare that to the results from your initial analysis. It might be like, still looks like nothing, or like, oh, maybe there is something more interesting when I look at a larger data set. So that's the first step. The first step is just comparing the smaller data set that you've already looked at to looking at your hypothesis with this extended data set and using the computer tools, which will help you do this much more easily. But then there's more, too. So I've mentioned this before, I'll mention again. Often what's really interesting is not what you were originally thinking was going to be interesting. So it's always worth looking beyond your hypothesis. So instead of just checking your hypothesis and stopping there, you know, look for correlations in all the variables. Not just your hypothesis. So the thing is, you've got all this data, play around a little bit. Okay, so maybe my hypothesis isn't supported. Let's look at the rest of the stuff. And maybe there's some story there that is interesting, but it just wasn't the story that I originally thought would be interesting. So by the time you're done, you should have graphs for height versus jump height, calf versus jump height, weight versus jump height. You know, we have sex, gender stuff. Look at men versus women's jumps. You know, so the point here is you go beyond your initial hypothesis and just look at everything and see if, is there an interesting story there in any of these variables. And three, I would say, you know, look at whatever else you want. Look at other things. Again, like, you know, male versus female, which wasn't in any of our initial variables, so to speak. You know, I'll show you a few examples. In fact, I'll show you a couple of examples where this gets really interesting, where you can play with the data in more creative ways and find something interesting that you might not have found if you just like got kind of lazy and it's like, oh, it doesn't look like anything there, I'll walk away. But if you spend a little bit of time playing with it and analyzing it, you might find there's interesting stories there that weren't so obvious in the beginning. So I'll say, like, you know, be creative. Play with the data. Minimally, you need to check your hypothesis again and compare to the initial results. Minimally, you need to look for correlations across all the variables, not just your hypothesis. And then, it's also nice to kind of look even beyond. And again, I'll show you some nice ways to do that. So are there questions or any comments about the expectations? This is going to be like, due in 2 weeks as the final graded jumping lab. It's going to include the stuff you've turned in so far, the pre-lab, the initial analysis, but then the extended analysis. And that will ultimately be turned in 2 weeks from now. There's a Zoom link already in the, not a Zoom link, a submission link in the module where you're going to turn this in, just like the chemistry lab. You had 2 weeks to do the final thing. You can turn it in way before if you'd like as well. I recommend keeping up on these things and not letting them pile up, but I give you 2 weeks because that way I know life can get crazy. Any questions about what's expected for this? Sienna.
One comment you made on mine was to submit it as, I think, individual pages. Is there any way you can show me how to do that? Because when I use my phone, it just comes up to scan a page and then to scan another page and then submit.
Which app are you using?
I'm just using what am I using? I go through the Canvas portal and then it just asks me to make a submission and then it asks me to scan with my camera. So I'm not using an app.
So you should use like the Adobe Scan app.
Okay.
It lets you scan all of your things, makes a PDF, nice, pretty PDF with all the pages. There's a few people, I would think, is it Michael? Some people are using the scanning, but then putting it in like landscape mode. So the pages are all stretched out and like sideways. There's also options for, I think, trying to remove different colors, but you don't want to do that. Like some people have been turning some of these scans in, but all of the graph lines have disappeared because the scanning app is trying to get rid of guidelines. So yeah, I think on the one that I've been using is this scanning app. I'm going into my modules right now. Hold on a sec. La, 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 la. I'm gonna share.
Do you have an iPhone, Sienna?
Yes.
So if you go in the notes, make sure you're on like the iCloud notes. If you go to like take a picture, it'll say like scan or photo, and then you literally just hover your phone over your document and it'll capture it and save it, and then save it, and then you can just upload it to your computer and it'll be a PDF.
Okay.
I feel like that's what I've found is the easiest way. I don't know if that helps.
You can also just hold notes down instead of opening it. Just hold notes down and it says scan document and click that, and then you automatically just do the same thing, like hover it over, and then you save it to your files on your phone.
And then upload
Go
it.
to share, save it to your files, and then you can easily upload it under files from upload document.
Okay, thank you.
Yeah, you can do multiple scans too. So you don't have to do just one and then save it and then another and save it. You can do all of the pages and then save it. That way it's all saved under one as well.
Yeah, like it'll capture your first photo and it'll like bring it down to the bottom and give you another camera view to take another picture.
That's what it does for mine. I don't know how mine ended up being. You want it as multiple pages or you want it as a single PDF?
Single file.
As a single file. So you take the multiple pictures and at the bottom right, it'll say save, and it'll take all those pictures together and put them in a document of a PDF.
Okay. Thank you.
So yeah, thanks. So this is cool. I didn't know that Notes had this feature. I think when we started this a year ago, Notes, I don't think Notes actually did it, or at least I didn't know that Notes did it. It could be like post, now that everybody's on Zoom submitting assignments through PDF, the engineers at Apple decided, oh, we should just add this to the normal app.
Can I just say one last thing on this, as a plug for the Adobe app? If you do all your scans through the Adobe app, it links right to Canvas. So it's all right there. Like physiology class will come up and then you can just share your document right through the Adobe app.
Wow, so that's new too. Holy crap.
Canvas also has a, when you go to submit the assignment, if you have the Canvas app on your phone, you can do it directly through Canvas. So you don't have to worry about saving it or anything. I just take it on my phone. the Canvas
That's what I did. I don't know what I did wrong.
Yeah, so it sounds like there's more than one way to skin a cat here. So as long as whatever you're doing is putting in legible PDFs in a proper form, yeah, I don't care how you get it in there. So, and I'll keep, if the things that are coming in are looking weird, I'll just send you feedback so you've got like a chance to try to do something different.
I have one more, I have a quick question. So we should have basically at the end, we should have at least like 4 graphs. Is that
Yeah.
correct?
Yeah, minimally like 4 graphs,
Okay.
right? Because you're going to have the main independent variables as well as BMI. So,
And you know, you don't have the other information, like the other data available for us to select, right? It says it's not available till the 9th at 8 a.m.
wait, so I just went into Jumping Lab Extended, unlock September 9th. Today is, oh, September 9th. This is not September 9th, is it? Good God, hold on. Today's September 7th. I'm going to edit this. I'm going to lock until September 7th. All right. Thank you for letting me know there. All right, so let's take a look. So yeah, I put here, I think I put this, I made it bold and highlighted because every freaking semester, people will turn in their final lab and they'll only use one variable. And I'm like, dudes, we talked about it. It says, regardless of your hypothesis, make sure you analyze the data to look for trends in all the independent variables. Repeat, regardless of your hypothesis, make sure you analyze the data to look for trends regarding all. So, please don't turn in your final lab just looking at one variable, because it's like, you want to look at all of them, please. And again, I wouldn't, if you look at this and say like, he's being goofy, why is he doing this? It's because consistently over semesters, people just turn these in and somehow don't hear that. All right. And I should also mention, there's a couple of YouTube things that are in this. I'm not going to play them through right now, but they look over things that we're about to talk about. This one here is something Tina made, lasts like 8 minutes on ways to deal with graphing the data. This one I made, it's a little longer. This one is like 25 minutes and it's looking a little more in depth at how you use data series and separate out like different groups on the same graph. Like if you want to look at men or women or healthy or unhealthy BMI, but with the same height versus jump and stuff. So we'll do this in person right now. I'm going to show you lots of ways you can play with the data. But when I'm done yapping, and you want to kind of go back, you can look at these, and I do my best to explain this as well in a kind of what is it, asynchronous fashion. So, all right. So first thing I'm going to do is just get this data. And I'm going to say, let's just kind of save this. We're going to open it. So here is my data. The first thing you will probably notice when you open up the data, there's different colors. The colors are just there because I was being kind of clever. The morning section, which would have been like you guys before COVID, is kind of like the golden dawn. The yellow is the, unrelenting sun of midday. And then the blue is like the evening section. Kind of moonlight, midnight blue. Sex, weight, height, calf, jump. You'll notice that I don't have BMI in there. That is because whenever people calculate their BMIs and put them in manually, people make lots of mistakes. If you look at any one person, they probably do math problems right. If you look at 90 people, there's going to be like 10 people who did it wrong. So whenever you have some repeated mathematical thing to do, it's always better to just let the computer do it. So I have this set up. Maybe I'll increase the. I want to put my BMI in here, and I'm going to let the computer do it. So before we go here, actually, let me do a quick little aside. How many people have never used Excel? So raise your hand if you've never used Excel. Well, this is awesome.
I've used it, but it's been a long time.
All right, but so, as the years go by, in the beginning, it'd be like tons of people have never used Excel. So things to remember, I'll just give you a few things to just keep in mind as we start this. Each cell is got its own particular address, right? This would be like A1, this would be like B1, C1, A2, A3. It's like a big ledger sheet. Up at the top, there's this thing called the formula bar, which is going to be important to pay attention to. What can go inside any of these cells? What kind of things can you put in a cell?
Numbers, letters, pretty much anything.
So numbers, letters, I'll call them labels. So label like, sex. That's, just letters, and then if it's an F or an M or whatever, I can have label like weight, and then put these numbers in, which would be like, 56.4 or 68.9 or whatever. The labels are going to be important just so you can kind of keep track of what's what. It's always important to lay out your spreadsheets in ways that they are easy to work with and they're clear what you're looking at. The numbers are always just numbers. If I type in 68.9 into this box, up in the formula bar, it's going to tell me it's 68.9, which is just a number. How I actually display that, though, can be formatted in lots of ways. I can say, I want you to display it as money, in which case instead of looking like that, it's gonna, you'll look in there and it's gonna say, whoops. It's gonna say, oops, we said $68.90. Or I can say I want it to be a percent, in which case it's gonna be 6890%. What is in there is still just a 68.9. You can define, you can round it, you can tell it how many spaces past the decimal point you want displayed. But if you're ever curious what's actually in the box, you can look up in that formula bar. So there is one other, I would say not almost anything. There's one other major thing we can put in a box, in a cell. What's the other thing we can add in?
A formula.
A formula. So formulas are going to be mathematical combinations of other things. They always start with an equal sign. Like if you are having trouble, like your formulas aren't working, often it's because, I forgot to put the equal sign to begin the formula. So equals, and then you can just do mathematical mixes of things, you can use pluses, you can use minuses, multiplication is an asterisk, division is a thing. How do I do powers in like alphanumeric characters? If I wanted to do like x squared, how do I do that on a computer?
The little caret.
Yeah, it's x caret 2. This is what x squared means. So for our BMI, what is the formula for BMI?
Weight over height.
Not quite. More? This is not right.
Height over weight. Oh, wait, is it weight over height times 100 or something like that?
Does anybody have their lab book in front of them?
Yeah, it's weight
over
over
height.
height squared.
Squared, sorry.
It's weight, and it matters what the units are too, right?
Kilogram.
Weight in kilogram over height.
In meters.
Height in meters.
Meters.
Squared.
Squared. So that is the formula for BMI. So on our, in our spreadsheet, we're going to have to come up with this, but we have to write it in our program. So we have basically, let's go back now and share. So for BMI here, I'm going to say, if I'm going to make it a formula, what does it have to be? What's the first thing in this thing?
Equals.
Got to be an equal sign. If I don't do the equal sign, the rest of it's not going to work. It's got to be equals. And then I need to have the weight in kilograms. Which cell for this subject has their weight in kilograms?
B.
B2.
Be B2.
Two.
All right,
B1?
and then
Oh,
what do I want to do next?
Divided by.
Divide this.
Divided by,
Divided by.
what's that? And then what do I need next?
C2.
Squared.
Right, so C2 squared, but not just C2, right? Because C2 is in what units?
Centimeters.
Centimeters.
We need it
Centimeters.
to be in meters. How can we convert centimeters into meters?
Divided by 100.
Just
Divided
divided by 100. Right, that is going to be their height in meters. Right, and remember, if you're ever like kind of confused about, do I divide or multiply times 100, just do it and see, use that sanity check. Like if somebody is 162 centimeters, if I multiply times 100, are they going to be 16,000 meters, 16 kilometers tall? It's like, no, that makes no sense at all. So I better divide by 100. That makes more sense. And you can use your sanity checks here. And then we want to square it, which we talked about, just doing that little caret. If you remember your precedence of operators just from, basic arithmetic, remember it's first you do parentheses, then you do exponents, and then you do math, multiplication and division, right to left, and then you do addition and subtraction, right to left, my dear Aunt Sally. So this should do it. Does this make sense? Like why this equation? So if I hit return, there it is, 21.4. There is their BMI. It's important to notice that if I click in that box and I look up in the formula bar up at the top here, notice that you see that it actually is a formula. That what's in my box here is a formula. Whoops. But it's going to give me the result of the formula here, 21.4. Rather than writing the same formula just shifted by one number for each thing, it has the cool little feature that if you highlight this frame that has the formula that you want, and you'll see there's a little like square in the lower right-hand corner of this cell. And I'm going to float the mouse over and you can see the mouse just turned into a plus sign. When I've done that, when it looks like a plus sign and I hold down my left mouse button, kind of the action button, and I just drag, I'm going to drag all the way to the bottom of everything. And I let go of my mouse button, ka-ching. It just has the same formula. If you look now in the formula bar, it's the same formula, but just adjusted for each appropriate row. So now all of a sudden I have perfectly calculated BMIs for everybody. I'm gonna zoom out a bit. I want to make sure the colors kind of match because it's prettier. And also as we start rearranging things, having the colors lined up is going to be important because you can see if something goes wrong, if one column is getting disconnected from another. So I can just select these. I'm going to go, I actually made the colors standard, so it's easy. I'm making those yellow. I'm going to make these, turn them back to blue. At this point, I have got my data ready to go. I got the BMIs. I got it pretty with all the colors, actually all appropriately corrected again. What do I do before I do anything else now, continuing my analysis?
Save.
Save. Save early, save often, right? Things always go wrong, things mess up. So I'm going to go and I'm going to file, I'm going to save as, and, it's going to be, like, working copy or something. So I know whatever goes wrong, I can come back here. If I'm doing stuff and it's a dag nabbit, now what do I do? What do I do if I make a mistake and I did something I didn't mean to do?
Control Z or Command Z undo.
Yeah, or you can go up at the top, a little undo arrow. So that is just a kind of a miracle friend. Whenever something goes wrong, you can always just rewind. I wish other parts of life had a little back arrow. So just kind of getting comfortable in here. So now we're looking at the time. What I'm going to do is I'm going to go through just a few different ways to think about using Excel and this big data sheet. I am not expecting, if you're used to using Excel, you're going to say like, oh, that's totally easy. If you're not used to using Excel, you might get a little lost as I'm going through. Don't worry. Just, it's more to show you what's possible, and then you can kind of go back and find out the details of exactly how to do it, either on your own or looking at the videos, or I'll be here helping people out as well. But what I want to do is just kind of illustrate some of the basic approaches to using Excel to make the basic scatter plots, to make the basic bar graphs that we're interested in, and giving you the basic, idea of how to approach analyzing the data. And once you analyze the data, then you put them in your lab book, give them figure numbers, and then you can just write up your discussion referencing your graphs and stuff to support whatever conclusions and discussion you have. So somebody was saying height versus jump. So let's say I want to get a scatter plot of somebody's height versus their jump. So one of the things that I tend to do is I do things on separate, these little tabs at the bottom, it's like gives you different pages. I tend to, here, I'm going to take all of my data here. If I just click in the upper corner, it's just going to copy everything. And I'm doing my the right click, the right button just gives you a context sensitive menu. And it says like copy. I'm going to go to sheet 2 and I'm going to just paste it here. It's just a copy of my data. So whatever I do, whatever graphs I make here aren't going to be affected by things on the other page. I am going to take I want to make a graph of, I want to do a scatter plot of their height versus their jump. One thing to remember is that Excel wants to be your friend. It wants to make your life easy, but it will often assume things about what you want to do and make wrong assumptions, especially in these more kind of complicated graphs. So I find whenever I'm making a graph, I want to make sure that I select some cell that's away from my data. If my cell is selected inside my data here, when I tell it to insert a graph, it's going to assume, I'll show you. I accidentally forgot to click out and I'm going to say, oh, let's insert a scatter plot. And it's like, oh crap, that's nothing. This is garbage. This means nothing. It's pretty, but it means nothing. So I'm going to like get rid of that because that's meaningless. And I'm going to put my selected thing away from the data. So it's not going to make any assumptions about what I'm trying to do. And now I'm going to say insert scatter plot. Now, so you don't want to connect the dots, right? You just want the dots for each data point, and then we can tell it to add the trend line. So here is my tabula rasa scatter plot. There's nothing there yet. So what I'm going to have to do is tell it what data do I want to graph in there. There's a few different ways you can do it. There's select data up at the top here. You can see, hopefully you can see as I'm moving my cursor around. I also just tend to use the right click. The right click on my mouse button is context sensitive menu. It's like, oh my God, select data. But there's lots of ways to, what is it? More ways to skin a cat, kill a bird, do whatever. So when you are selecting your data, it's important to understand the idea of series. Each series is just a collection of X and Y values that it's going to put on the graph. If you're only graphing two things, you only need one series. You're going to see, though, that series can be really interesting. Like if you want to have like, height versus jump for guys versus for women and on the same graph and have it clear which is which. But for right now, we're just going to add a series. We don't even have to give it a name because there's just one series. It's just going to be their height versus their jump height. So I'm going to say X value. What are the X values going to be if I'm going to graph their height versus their jumping height?
Height.
It's going to be their height. Remember the independent variable on the X? So if I just click this little arrow dealy bopper, and I can just actually go here and select all of the heights in this thing here. And I can double check. It's saying C2 to C79. Again, that sanity check, that makes sense. C2 to C79, that is the range of data that includes everybody's heights. The little $sign just means absolute address versus relative address. You don't have to worry about that now. For the Y values, I'm going to click on this little arrow thing, and I'm going to just pick all of the jumps that go with all of those heights. Doobie-doobie-doo. And hit enter. And again, I want to double check. Y's are F2 to F79. That makes sense. If the numbers don't match up, something went wrong in your selection, so you got to correct it. Also, make sure that there's no labels. If you accidentally get a label instead of just numbers in here, it's going to totally make things weird. So I say, but that looks good. I'm going to say okay. I'm going to say okay. And there are all of my data points. First thing I notice, I can add a chart element. My axis title, horizontal is going to be height in centimeters. You always want to label your axes. If you don't label your axes, you are going to get a big red mark on your thing. This is going to be their jump in centimeters. So here I have the jump versus height. Notice it's what I was saying. You don't want to start your axis from 0 here because most of this is empty space. So if I started at like 140, that's going to include all my data and spread things out. Again, I can just go hover my mouse on the X-axis. I use my right-click button. My right-click is my context sensitive. It's like, oh my God, there it is, format axis. And it says minimum. Okay, instead of just 0, I'm going to have the minimum be 140. Now it's all spread out kind of nice. I could give it a title if I wanted here, like height versus jump. So here it is. What's the last thing I want to do here to really see what this has to tell me?
Tick marks.
What's that?
Tick marks.
No, the tick marks are there.
I know.
And if you want anything, timer.
Your line of regression?
Do the line.
Yeah, the regression line, the trend line. So to make it calculate that automatically, all you need to do is click on the dots. You'll see that the dots look like they're selected. And again, you can just right click again while you're there because that's the context sensitive menu. It always comes up with appropriate options and add a trend line. Ka-ching. There we go. There's my trend line. You can do linear, for our purposes right now, a linear trend line makes the most sense. So here we have this nice graph of height versus jump with a trend line. What would you interpret this? What would you say this is telling us?
It's a positive
correlation.
Yeah, it seems like there's a positive correlation, relatively reliable. It's definitely got some kind of a slope to it. Things are, it's pretty noisy, but, it looks believable. So here we have, looks like height really does have some bearing, right? It doesn't mean it's absolute, right? You can have people who jumped higher that were shorter and people who jumped lower who were taller. But in general, taller people seemed to jump higher than shorter people. You know, and then you could either print this out as a thing, or what I tend to do, since everything in Microsoft moves back and forth between the different apps, what I tend to do is, let's take this and let's copy this graph. And I'm going to go into Microsoft Word. Let's see. Here's Microsoft Word, and I can just paste my graph there. And now it's kind of smaller when I'm printing. I can actually put a number of graphs on the same page. Let's, you know, and I can resize them and print them into my, print them out however, you know, so they fit nicely in my lab notebook. So I tend to move things into Microsoft Word to be able to resize them and make them a nice size to put into my lab notebook. And in fact, now I'm looking at this, I should probably start from 145 instead of 140. And that's, again, that's super easy. All I have to do is I go back here, format this axis, and let's go from 145. And it spreads it out a little prettier even. In general, if you want to see if there's a nice trend, you tend to want to have an aspect ratio, kind of like a TV screen. You know, you don't want to have everything squished together because then it's hard to see what the line is doing. So any questions about like how, you know, this basic idea to make a scatter plot? You know, you're going to want to do this for all the main things, for their height versus jump, their calf versus jump, their weight versus jump, and see if the trend line seems to suggest a relationship or not. What I'm going to do next is show you how things can get a little, or how to rearrange data, how to sort things, and then also why sometimes looking a little deeper is useful. So I'm going to go on to, I'm going to copy my data. I'm going to make yet another one. I'm going to work on sheet 3 here. What I'm going to do is I'm going to sort the data by sex. So I'm going to choose my data here. Up on the top, this data menu lets you do sort. Because we have the labels, we can say, what do we want to sort on? I'm going to sort on sex. Ka-ching. I now have all the women on the top, all the men on the bottom. It just sorted it alphabetically. It's the same data. You know, notice that everything is still, like, one of the dangers sometimes is people only like select something, you know, like, right, it's here, it's warning me like, oh my God, like I just sorted one thing, but I didn't have it connected to the rest of the fields, right? If something like this happens, it's like, oh, I gotta go back because something went wrong. That's part of the reason I like to have the colors all lined up. So here I have all the women and the men separate. So let's say I wanted to know whether the average jump for women versus the average jump for men. To make a bar chart, right? This is going to be a bar chart rather than a scatter plot, right? Because it's two categories, men versus women. I find for doing this, it's worth kind of going off on the side and just doing a little thing. I'm going to say average male jump, average female jump, and I'm going to want to insert the average jump for men. All I need to do is there's lots of functions. I can go into this little F thing, this function, insert function, and average is one of the functions. All right, let's pick average. And then I just have to select all the jumps that are from the men. It's these ones here. It's easy because I sorted it. Ka-ching. Again, if I look in the formula bar, it's just the average of cells F59 through F79, which are the jumps for all the dudes. If I want to get the average jump for females, it's, oh wait, I just messed this up here. Back. Let me get this fixed again. I just messed it up. There we go. Okay, so average female jump, I'm going to also insert an average, but I'm going to do the jump for the women. So all the Fs. There's an average jump for female. And if I want to graph it, doing bar charts is something you can let it do automatically as long as you have the data kind of separated like this. I'm going to select my labels and the values. I'm going to say insert a bar chart. And there I go. Here's a nice little chart. Average male jump to average female jump. I can add chart elements. Axis, title, primary, vertical is my average jump in centimeters. So, this is a nice little bar graph that would look at male jump versus female. We see on average, men jumped quite a bit higher than females did. If you were going to do BMI, healthy versus unhealthy BMI, you could do something similar. Again, I would do it yet on another page because every time you rearrange things, other stuff gets all messed up. So I'm going to put all the data here. And I could go into my data sort, but now I'm going to sort by BMI. Now I have BMI from lowest to highest. I could just do average of pick all the jumps for the people with the BMIs in the healthy range and get their average. And then the BMIs of the average of the non-healthy people. So, you could do the same kind of thing, a bar chart of healthy versus unhealthy BMI, if that makes sense. But, just sort your data by BMI. If you're trying to select data that's not continuous, you just have to hit, I think it's control. Yeah. Every time I hit control, I can get other sections that are not continuous with each other. So if I have this jump for this unhealthy person, and then the jump for all of these unhealthy people, I can have an average of this along with these, if that makes sense. Is that making sense? Right, so just kind of putting out there how you do that. Another thing, since we're doing this thing showing, okay, well, I like to do this. Height versus jump. We say in general, taller people seem to jump higher. We also have this interesting thing, on average, males jump higher than females. So one thing we can do that's pretty fascinating is this. I'm going to take my data again. I'm going to sort it by sex again. So I have men and women separate here, but I'm interested in the jump heights versus height, but just for the men or just for the women. But I want to see if we just look at women or just look at men, do we see different trends? And as we've just looked at from these previous graph, men and women in their jumping do seem kind of qualitatively different here. So I'm going to make a scatter plot. I'm going to insert a scatter plot. And I am going to do the same thing of height versus jump height. But when I'm selecting the data, I'm going to have my first series is just going to be the women. So women, I'm going to do the X values for the women. X values for the women is going to be their height. Hold on, let me cancel this for a second because I need to get this out of the way. All right, I'm going to do select data. add just women. X values for women are going to be their height, but only for the women. So down to 58, because below that we have males. The Y values, their jumping height is going to be their jump height, but again, just for those same ones for the women. Ka-ching. Okay, and I'm double checking 2 to 58, 2 to 58, it all looks good. We're going to add now the men. Let's just look at the men. We're going to do the X values, the height just for the men. Ching. The Y values are going to be the jumps that go along with those. Double check 59 to 79, 59 it all looks good. Okay. All right, so there it is. And then I'm going to also change this, format the axis to 145 to spread things out. Now it's looking kind of interesting. If and I'm going to actually add my data labels, not data, legend. So you can see which are women, which are men. I'm going to add my axis titles, primary. This is going to be height in centimeters. You always want to have your axis titles. I'm trying to model good behavior here. Primary vertical is jump in centimeters. So now if I click on the women and add a trend line for them, click on the men and add a trend line, click on the men, add a trend line, I get something really fascinating. What do we see?
There's a positive and a negative correlation. Positive with the women, negative with the men. Is
I
that
mean,
right?
and I would say that tiny little angle you're seeing there, Holly, is meaningless. Like if that's almost horizontal to me.
Is it just for the men? Is that just the men, or is it both of them?
Neither of them have any correlation. Both of them, when I look at these, I would say if you're just looking at women, there is really no relationship between how tall they are and how high they jump. If I look just at men, I don't see really any relationship between how tall they are and how high they jump. But we can also say, typically, there's a few things. I mean, in anatomy, if you remember the epiphyseal plates, women's epiphyseal plates close quite a few years earlier than guys. Guys have a few more years to keep having their long bones get longer and get taller than women do. Guys tend to end up being taller overall than women end up being. Also, guys have testosterone as their primary sex hormone, which is much more anabolic than estrogen. Just the same activity with lots of testosterone is going to be less fat and more muscle versus estrogen, where there's going to be not as dense muscle and more body fat. So when I look at this, it's like, this is telling me men tend to be, if I look in general, yes, taller people tend to jump higher, but that's because guys tend to be taller than women and guys tend to jump higher than women. So the story is way more complicated than just like, oh, there's a positive correlation between height and jump height. If you start pulling it apart, looking at by sex, it looks a lot more interesting. Does that make sense? Yeah. I'll do one more. It's kind of fascinating. Again, I'll take the data. Actually, I had the data sorted by BMI. Let's just do that. So here was the data sorted by BMI. So I'm going to first I'm going to look at calf versus jump. We're going to look at, I'm going to insert the scatter plot. I'm going to say, all right, for my data, let's not worry about anything first. Let's just look at the calf circumference. Whoops, I messed something up. Hold on, delete, add. We're going to look at calf circumference, which was what? There we go. The Y values are going to be the jump that goes with those calf. Ching. Okay, okay. So now I can also label, add chart my, this is calf circumference. This is going to be flat. My jump in centimeters. I also can see nobody had a calf smaller than 30, so I'm going to format the axis. So minimum is 30. Spread it out a little bit. Looks good. Next, I'm going to add a trend line. Does there seem to be a relationship between calf circumference and jump when we just look at this?
Doesn't look like it.
It doesn't look. What else could, how else could we look at this more deeply to see if there's something going on?
We could look at gender. We could separate it out by gender with calf circumference as well.
And what else? When we talked about calf circumference, the people who talked about calf meaning like more muscle.
Or weight.
Say it again.
Weight.
Weight, not necessarily, because already you can be like really big and ripped, or you can be really big and obese. BMI. We talked about in general, like healthy BMI would mean a more healthy ratio of fat to lean tissue. You know, so what if we looked at calf versus jump, but rather than looking at everybody, we just looked at the people who had a healthy BMI, where it's more likely that their calf circumference actually is related to their muscle versus just, you know, obesity or fat. So what I could do is, in fact, I can do it on the same graph. I'm going to say select data. I'm going to add a series, and I'm going to say just the healthy BMI people. And the X values are going to be the calf circumference, but only the people who have healthy BMIs, which goes to 24.9 here. And so it's 3 to 54. I need to have their jumps as well. Okay. I'm going to add in another one that is just going to be the unhealthy BMI people. And again, the X values have to be a little trickier here. I can pick the calf for this person who's below 18. And then I'm going to hit control, and I'm going to get all of the calves for the people that are 25 and above. So then I'm going to have to get the jumps for those same people. Here's this person, and then all the jumps for those people, which is going to be up to here. Ka-ching. Hit OK. Okay. So here's my data. Let me like what I'm gonna go and I'm gonna get rid of select data. I'm gonna get rid of the original one because it was it's kind of making things harder to see. I'm gonna add my legend so we just see which is which. If I add a trend line for my healthy BMI people versus calf versus add a trend line for my unhealthy people, yes, it's kind of amazing actually if you look at that. For the people with healthy BMI, it actually looks like the larger the calf, the higher they jumped. For the people with unhealthy BMI, the larger the calf, the less they jumped, which is kind of what you'd expect. So just kind of putting that out there, by looking at the data more deeply, you can often find something that's actually interesting that you'd miss if you were just kind of just glancing at it and just saying, well, it doesn't look like there's anything here. And just kind of getting you guys in that mode of thinking like, it's worth it. It's kind of fun looking at the data more deeply. So I'm going to stop sharing this. Are there any questions about kind of what I've been showing you here? Right. I mean, that's one of the, normally if we're on campus, then we can just, hang out, and there's usually people working in the computer labs to help you if you're not as used to using Excel and making the graphs. What I'm going to do is I want to talk a little bit about kind of the next lab, because we have to think about a pre-lab again. But in terms of the jumping lab, all I'm asking you to do is use the extended data set, use Excel as a tool, just to look deeper into this data, look at your hypothesis, then look at the rest of the variables as well. Do the basic analysis, get the graphs printed out so you can use them to support your discussion and your conclusions, and then write that up, and that will be what you turn in as the final jumping lab. So are there questions about that?
Do you want us putting the data in or just the graphs?
You don't have to put all that whole list of data, because the graphs will represent all that data. So there's no reason to have the entire individual numbers in a big table like that.
Okay.
And when we submit the completed final lab, are we submitting the entire thing or just the parts we have not already submitted?
No, the entire thing, from the methods and objective and hypothesis all the way to the very end, because that's going to be the final grade. The initial grades are, you get minus if you don't do them, but if you do them correctly, you're at 0. So it's kind of like the just making sure you're standing at the takeoff point. And then once you're at the takeoff point, then you can turn in the whole completed thing, and that will be the formal grading for the jumping lab.